All right, let's try this again. Good afternoon, everybody. My name is Rob Romanowski, Director of Sales Operations with 3HTI. And today we're going to talk about generative design and generative topology optimization. And this is a really cool tool for Creo that allows you to work with different options and different ideas to get your design the way that it needs to be regarding using the least amount of materials to get the most amount of strength out of it. This is a really cool tool. Paul Dye, who's from the Virtual Center of Excellence, is going to take us through a presentation and a live demo regarding this tool. And there's actually two tools, and he's going to explain the difference between the two. So if you have any questions, please put them in the Q&A section. We'll answer them as we go along. And Paul, you have the con.
All right, Rob, you can hear me okay? See my seat and my
screen. I hear you loud and clear. I hope Zoom is nicer to you than it was to me.
All right, me too. So thank you again, Rob, for having me on. Thank you, everybody, for jumping on as well. And you might know me. My name is Paul Dye, solutions consultant and application engineer here at PTC. And definitely a joy to go through and talk a little bit about generative design in Creo. It's, I'd say, within the category of our emerging technology from within Creo, something that we've had for a few releases now, and something that is really getting a lot of good use and is becoming more and more powerful with every single release. So I can go through today and explain exactly how we look to utilize it, where it's useful, what it actually looks like from within the context of Creo. And I'll explain some of the differences in terms of the actual tools themselves that we work with. There's two main ones, the generative topology optimization tool and also the generative design extension. I'll explain the differences between the two. If there's any questions throughout this, feel free to drop those in the chat. We can definitely get to those at any point. Even if it's just anything that you want me to elaborate further on, I'd be more than happy to do so. All right, so without further ado, we can go ahead and jump into it. And one thing I always like to do before we really talk to any of these different tools is explain some of the main challenges that we typically really see throughout the process. And this just goes back to regular design, right? Regardless of anything that you would do from generative or topology optimization, we have to have a focus on driving innovation, whether it's for making improvements to a previous design or creating new products that haven't been introduced to market yet. It's true in many different industries. You have to be able to create designs that not only satisfy the work that you need to do, but also has to be interesting, either catch the eye of consumer or simply differentiate from what's out there, or just do it better. Be more efficient, be stronger, be lighter, anything along those lines. We have to be able to incorporate that into our designs. We also have the idea around a closing skill gap. We see a lot of industries where we have certain workers that are beginning to retire. We have new people coming in, new designers coming in, and they don't have the same level of industry knowledge or experience to be able to go through and design, right? And that could be a benefit, but it could also be a challenge. If you don't have industry experience, you have to go through and learn before you can really contribute from a design perspective. So we need to be able to close that skill gap. And of course, we have to be able to accomplish more in less time than ever before. It really seems that every single year that passes, we have to be more and more efficient in the way that we build out products. And for us, or the designers, engineers, we need tools in order to get us there. So there's definitely a wide variety of considerations that we have to keep in mind as we're starting to build into the future of design. And one of the main ways that we have of really combating all those different challenges is with topology optimization, and specifically what we do from within Creo with generative design. There's two main components here of generative design, first of which being the generative topology optimization tool, or GTO. This is what we're going to be looking at today. And this is really the core for everything that we're going to be using in generative. And in short, it's our tool for autonomously creating optimal designs that we are going to get to from a set of system design requirements. That could include loads, constraints, or materials that you're working with, even the different manufacturing processes that you have available to you. And it's going to go through and build out those designs for us. Now, the second main section here is the Generative Design Extension, or GDX for short, which takes all the functionality that we have in the core of the GTO tool, Generative Topology Optimization. And GDX is going to utilize the cloud to not only simplify the process, but also to expand upon the capabilities that you have there. So first and foremost, I'll go through and explain what we have here in terms of our Generative Topology Optimization tool, or GTO. So this is where we're going to go through and lay out all the different design goals and requirements that we have for our use case, things like materials, physics, manufacturing constraints, a lot of other considerations. And the system is going to go through and generate designs that you or I probably would have never thought of, but we can use as the base for a product to further refine upon, or even just as a means of ideation, concept generation for different designs going forward. And from within Creo, you can run as many of these as you want. You don't want to find a design that simply just works. We want to be able to build out our designs with all our different goals, manufacturing constraints in mind, and avoid any level of over-engineering. Simply go through and make sure that what we're doing is optimized from the get-go. And while you're going through and building these designs, you're able to visualize real-time what generative topology optimization, or GTO, is creating. And that's even true whenever you go through modifications to your input geometry or any of the criteria that's defined in the study. And you'll see whenever we go through and work through a couple of different examples, right from within GTO, you have the ability to interrogate and look at stress values that you're seeing in the model, get an understanding of how the model is going to deform based on the use case that you laid out. And part of the reason that we're able to do that is because it's all integrated right from the Creo. So we took what we have in this generative tool, built it right into the modeling environment. It's not a separate window or different software we have to switch over into. You just go through and build out the design. And once that system it generates the design, you've had the chance to go through and review it. You can go ahead and output the results into a full solid. And a lot of other systems, you're stuck with just a tessellated version of the model that you could go through and recreate on your own, or maybe put on a 3D printer. But what we can do is actually go through and get a BREP or boundary representation solid of that model that can be manufactured. It's going to be a true solid that's going to be able to be taken forward into any of the other areas that you work with from within Creo. So that's the main tool that I'm going to be going through today and showing all the standard capabilities that go with that. But I do want to give some context into the other area here with generative design. So this is our generative design extension, or GDX, and it's taking all the functionality that we're going to go through today. But what it's going to do is add a little bit on top of that in terms of how much that you could run with this. It's utilizing the cloud now to enhance the different abilities that we have within generative design and take it to the next level. And it's one of the reasons that I always tell people that working with GTO, or generative topology optimization tool, first and foremost, is really going to be the foundation before you would ever move into, I'd say, the second level here with the generative design extension. So getting started into it, it's really a seamless process. There's don't have licenses or software you have to install that would be separate with this. We have a direct connection from Creo right up to the cloud with GDX. So essentially, just with one click, you could take everything that we built out normally and would run within Creo, but now we can utilize cloud computing to get those run through. So it's going to be able to look at many different design criteria simultaneously. You can look at lots of different combinations of manufacturing methods and materials. And once you've selected the studies that you want to run, we just click generate and GDX does the rest. So once the design has been generated, you can go through and do comparisons. You can see all these different designs stack up against one another. And once you've decided on one, you can bring that right back into Creo as well. So again, really taking what we have in the core of our GTO tool that we're going to be covering today, but really taking it to the next level if you really find yourself working with many different types of use cases simultaneously. Right, so we can go ahead and look at a demonstration here. Before that, I can take a stop if we have any questions.
We actually have one question. It's not a timely question, but basically the question is, for a company that works mostly with sheet metal, is there a solution to optimize a 2D pattern for sheet metal parts?
That's a good question. It wouldn't be done from within generative for sure, but potentially could be a use case for something like behavior modeling from within Creo, where you could do optimization feasibility studies. That could be done for different dimensions on a sketch per se, that would then drive your 3D sheet metal parts. That would be more of a behavior modeling type use case, which is a different extension that we have from within Creo.
Yeah, so I'll get back to you. We have one of our reps has a whatchamacallit, quite a few clients that handle sheet metal. So he's like a guru when it comes to making sheet metal parts. So I will get back to you with some more information regarding a better way. Next question is, what if your bounding volume was thin wall shaped?
Yeah, and is that in reference to generative? If it is, that's definitely something.
This might be in relation to the other one for sheet metal.
Yeah, in terms of what we do from within generative, it's definitely a roadmap item that we have to get added into the tool itself if we're looking to build into sheet metal. It's not necessarily something that we build right now with our manufacturing constraints currently from within the tool, but it is something that we're looking at and potentially evaluating for adding into the tool as a roadmap item going forward, specific to sheet metal.
Cool. Good deal.
Yeah, good questions though. All right.
And I do have that picture that I want to share at some point.
Oh yeah. Do you want to, and did you want to do that now, or do you want to wait until after the demo? Either way.
Yeah, you know what? Let me do it right now before you get into the demo, because this is
Yeah,
actually,
I think it's
actually
good context.
Really cool. So let me share my screen. Yeah, I can use this, but how do I share my screen? There we go. There we go. So let me know when you can see the table with the two parts on it. I think you should be able to see it now.
Yep.
Okay, so these two parts were made by Volvo Trucks, and they are actually we had about 4 customers at PTC's Virtual Center of Excellence up in or Customer Experience Center rather, up in Seaport in outside of Boston. And this was the original part, this big one here from Volvo, which was over 60 pounds. And it's pretty heavy truck part, but then you think, well, trucks are supposed to be heavy, but everything, if you can make it lighter, it's gonna work better. It's gonna use less gas, less fuel, just overall better to make a truck or an automobile lighter if you can. So this is the original part, and this is the part that was designed using generative design. And the parts have the same exact strength, which is kind of amazing. So this is the part now that Volvo is using in their trucks instead of this part. The other thing that what's really cool about this is not only that there's about a 40-pound difference between these two parts, but based on the overall weight, if you have to ship these parts in mass to a distributor, to a Volvo dealer, whatever, for maintenance purposes, you can fit more of these on the truck than you can these, or it'll ship lighter when you're shipping in bulk. So some good benefits there to being able to take your design from this to this right here. I thought that picture was really cool. So Paul, back to you.
Yeah, no, that is a lot of times very crazy. It's not only giving you sometimes even stronger parts, it's doing it with less material. And even in some cases, you're able to take parts or assemblies even that might take normally 5 or 6 parts to accomplish something. You could do it with just one generative part. So even in terms of increasing the use for a model, it can sometimes even decrease the amount of parts that you have to do, which is decreasing the amount of production that you have to do, the manufacturing processes that you have to run through. A lot of different ways that it could be very useful and really lower down the amount of cost that you have to go through in order to get something working.
Yeah. And it's shocking to see something that has a 40-pound difference and understand that it's just as strong. But this doesn't just work on big parts; it works on smaller parts too. Like I think what you might show here in the motorcycle.
Mm-hmm. And like you're mentioning as well, even if it's something where you're only saving a bit of material, if it's a part that's being manufactured, 100,000 times, a small material savings can really add up to a huge amount if you're doing something at a higher production scale as well. Because something similar to what you showed in your picture there is definitely something that is an interesting design, but would be something that would be more of a cast or something that would be 3D printed. But we're not just defined to that, right? We definitely play into a lot of different areas of manufacturing, things like 3-axis milling. I think this might be just simply extruded. So a lot of different ways that we could go through and utilize this as well. So with this, we can go ahead and just jump into it, right? So I'll focus up here at the top. This is around our steering mechanism. More specifically, I want to look at this lower yoke here. And right now, it might be a design that works perfectly well. but something that I want to see if I can go through and cut down on material around it, make it stronger. Just in general, I might know some of the different design goals that I'm after, but I'm not exactly sure how I'm going to get there. Well, that's a perfect candidate for generative topology optimization. So you can go ahead and select on that and get started here. And here I have that same yoke part, but a little bit more of a simplified version of this. So this is going to be the base that I'll begin to work off of here. And what you'll see is I'm working with two bodies here. First and foremost, we have in the gray, our overall envelope. This is in general where the part's going to be contained from within. So anything that gets generated will not go outside of the bounds for what that envelope includes. And then here in blue, we then have what's called our preserved geometry. In this case here, this is areas that no matter what, we want to make sure are going to be included in the final design. So in the gray area, we have the ability to build from within there, but these blue areas, we're telling generative that it has to include that. With that, that's all we really need to do to get into our study. Just go right up into our applications, select our generative design, and we can get into laying out our study. First things first, we'll go ahead and lay out some physics. And you could lay out, first and foremost, some constraints with this to say where the part's going to be held down. Right, so we can go ahead and get that defined here. It'll be right there in the pin in the middle. And then from there, we could say what types of loading conditions that we have. Be forces, moments, centrifugal forces, things of that nature. Get this all laid out here. And change around the values, change the units for whatever you need there. And now that we have some of our initial conditions, it's time to say what we actually want to design for, what our goal is going to be. In my case, I want to take some weight out here, maybe fill just about 2/3 of that volume. And then from there, it's what types of constraints that we want to lay out here. This is broken up into two main areas between geometric and manufacturing constraints. Manufacturing constraints are just what you might think if you need to take into account build direction for 3D printing, parting line for a cast, or linear extrude for an extrude, or even a 3-axis mill. You can go ahead and define that. Or it could be certain geometric constraints on how this is actually being built out. So material spreading would be more so in terms of the actual geometry that generative will build to you. It's going to either be more or less webbed, which you'll see kind of more of in just a minute. Or if we like to go through and make sure that we have planar symmetry at certain parts of the model. Say, for example, here, we want to make sure whatever is being generated over on the left-hand side matches the right. We can go ahead and define that as well. And then from there, we can lay out what types of materials that we're going to work with. The material is definitely going to change what we might get in terms of the results. Go ahead and use an aluminum alloy in this case. All right, final thing I can look at before I run the study is some of our settings. We have some options in terms of fidelity to optimize on speed or detail. You can change how many iterations that generative is running through here as well. But with that, we're good to go. All I need to do from that point is hit optimize. And now the system's going to go through and take the physics and the design criteria and build out our design. You can see while it's doing that, you can visualize real time what generative is doing in order to get to that intended shape. So you can see start to finish what it's actually doing in that process. In this case, you can see very quick to get results back as well. And from there, you can go through and see right on top of the model some of the results from the study. We can analyze that, take a look at our stress values, see exactly where we're getting minimums or maximums with that. See where we might be having some hot spots there on the model. Also take a look at the displacement, see if the part is deforming the way that it should be based on the loads and the constraints that we have set up. We also animate on that as well. If we need to get more of a visual perspective on what types of results that we're getting back there as well. And with that, we change the speed, change the scale. It's very much a visual way of doing that. And if we're not happy with the results that we got, just as easy to go back, change the definition of the study. But if I am happy with what I got here, what I can then choose now to do is generate the design. I'm going to take what would normally be tessellated geometry that I have now, and we're going to reconstruct that to a boundary representation or BREP that I can take back over into Creo Parametric. So rather than being stuck with a tessellated file like you might be in other systems, what we can do is get to real manufacturable surfaces that we can work off of. Now Creo is going to go through and reconstruct all that geometry that we just went through and built out in the study. And now it's just part of the Creo model. Something that I can take here, just add right back in with the rest of the part. And we'll use some multi-body functionality to merge our new geometry back in with the preserved geometry that we started with. And just like that, we have now a solid Creo model that's ready to go. But at this point, what happens if you need to go through and make changes? Maybe the model changes, possibly a certain dimension or diameter needs to move or it needs to be altered. Well, what does that do to my study? Do I have to go back and start over from scratch? Well, no. All we really need to do here is just redefine the study that we're already working with, put in a different design goal in this case, change around the constraints if you'd like to here. So we'll make sure it's going to be symmetric across that middle plane like we had before. But maybe in this case, we'll add in another constraint. We'll add in a linear extrude in this case. And this is going to be the case for a lot of people. Maybe you don't have a 3D printer to create the designs that you want to work with. Well, our system, not a problem. It's just as easy as defining those manufacturing constraints, saying what our material is. It's really whatever your specific scenario calls for. You can go through and get that laid out. And in this case here, I've already gone through and run the study before. So instead of running through back through that again, we can go ahead and just open up here in our file explorer the result that we got after converting to that BREF geometry. So whereas before that design was only possible to create using additive manufacturing techniques, you can see this is a type of model that can be created using your standard types of manufacturing, milling, extrusions. Just add that right back in with the rest of the model, and you're good to go. And now from this point, the idea is that this is integrated right back in with whatever else that we do from within Creo. We could take it over into our simulation tools. So as an example of this, we could use something like Simulation Live. If you've never seen this or worked with this before, this is something that we partnered up with Ansys to put real-time simulation capabilities right into our design environment. So even as we make changes to the model, the materials that we're working with, analysis definition, everything that we would do here would update automatically. And what I'll do here is put this through a structural scenario. It's actually carried over the loads and constraints that we laid out over in generative. And all we need to do is click the simulate. And as soon as you do that, you're immediately going to get results back. Now, what I could do from this point is go back and try out all different kinds of designs through generative. We just simply reconstruct the geometry, take the constraints and loads over into my simulation and see what types of results that we're going to get back. Looking at the results here, it's definitely a little bit different than what we would get from working with the additive model. Deformation around this outer hole seems to have changed a little bit. Animate on that to see what's actually happening with the design there. What we could do now is take that info, we could run more analyses, go back and build out more designs, or we could actually go possibly a different route with this if we'd like to. So rather than generative design automatically building out the model for me, and me just simply reconstructing geometry, what I also could do is just use that more as inspiration and more as a suggestion, and then go back and build out the designs using the parametric techniques that I'm already used to. So here is an example of a generative model that I went through, laid out my design spaces, physics criteria, and that's what the system came up with. But instead of using that design directly, what I actually have the ability to do is just use it as inspiration and then go back and, as you can see here, just build out the model using your standard types of parametric techniques. There's a lot of different ways to go through and work with generative, even if you're not planning to 3D print it or not even planning to use the geometry. It's still extremely powerful to be able to take that, use it as inspiration, and get to a less over-engineered model and a much more efficient model. And what we could do from there as well is jump right back over into Creo Simulation Live or CSL and see what types of results they're going to get back with this type of design. So building just off of the suggestions that we got from generative, are we going to see the same type of results? Well, just as easy, go back and work with it. Change the units, the display type, check out where the stress values are located, see where you have max values occurring on the model. Seems to be showing up around the same areas as that linear extrude part, but a little bit different from the additive version. But that's the idea. It's very easy to go back and try out lots of different kinds of designs, work with different parameters until you end up getting to a model that you want. And then from there, get feedback from your simulation tools, from your optimization on exactly how it's reacting, and keep going through and making changes. It's very much a very visual way of doing this rather than us as designers having to go off of gut feel or intuition. We can instead get feedback from Creo to tell you if the part's responding in the way that you intended it to based on the model that you went through and generated. Lots of different iterations that we could go through and do very quickly. And really, at the end of the day, you could have more than just one final design. And that's what I can go through and show here as well, is that we can set up different variations where we're going to have multiple versions of the part to accommodate different criteria. In this case here, I have an interchange assembly, which has some of these different models laid out. And in this case, we have different versions that we can utilize for different purposes. Now, with each of these, you can see how much weight we are able to remove with each design. And specifically, we're able to reduce the weight with the additive model by a pretty significant amount. And now what we could do is take those different designs from the original, the additive, the rebuilt version, and back over here in my assembly, I'm able to swap those out depending on what I want to see. So let's go ahead and use my interchange group here to select the one that I want from that family tree. So go ahead and take the rebuilt version in this case. And Creo will take that model, bring it right back into the assembly. We can see what that would look like there as well. All right, so that's really the main idea, is we're using generative topology optimization in our designs to come up with geometry, shapes, models that you or I, as designers, probably wouldn't have thought of by ourselves, but are going to be optimized for the things that we care about. It's maintaining all the structural requirements that we have, but minimizing the amount of material that we need in order to get us there. So at the end of the day, very strong model that we're working with in that case. All right, so with that, I can open up if there's any questions around that, or if there's anything that anyone needed to expand upon there as well.
No, this is very good. I think what I really like about these tools is that this has a tendency to be anything with what I see with a lot of PTC tools, like whether it's simulation, flow, generative design, even the GD&T advisor. I mean, these tools are to make, take the guesswork out and help designers and engineers be able to model a better part earlier in the design process to save a lot of time downstream and get something that works and works better. And it's also that idea of continuous improvement, where you're always trying to improve your product. And these kind of tools, like generative design and topology optimization, help you get there. They help you think out of the box and save money on your product, make it better, and hopefully get it to market faster, so that what our clients are seeing is being able to get products to market faster increases revenues. Question came in: what do you do if you do not know the loads, only estimations on the parts?
If you don't know specifically the loads, you could work with estimations. You could say, okay, we're going to take general areas, and you can almost take different ranges essentially of load cases. If you can get even close, right, it might be something worth where, okay, we don't know exactly the types of loads that we're going to be working with, but we know the types, right? Maybe not the specific values, but we know, okay, on these certain surfaces, we know that we're going to have a certain level of torque. We know that we're going to have an outward force on this. What you could do is essentially run a different range of values. So you could go from the low estimation to all the way up to the highest estimation of different types that you might expect, and then see what types of designs that generative would give to you. So it actually might create very different types of designs based on the low and the high ranges of those loading conditions. So as long as you know essentially the use case and the types of scenarios that model might be placed from within from a loading condition perspective, you can definitely go through and try out different types and then essentially just see the different types of designs that generative would ultimately give to you in that sense.
Cool. So if you guys have any more questions that you think of later, or want to get in touch with us for a more specific demo on this product or any other information, pricing, just, you can reply to the email that I sent out inviting you to this webinar, but you can also contact us at info, I-N-F-O, at 3hti.com, or you can give us a call at 866-624-3484, and be happy to help you out and see if this makes sense for you. So, Paul, thanks again for leading us and giving us a great presentation and demo today. We appreciate it. Most importantly, thanks to our audience for being on, and we will have another webinar upcoming in about 2 weeks, and the topic escapes me. So stay tuned for that.
That would be the design exploration.
You know what, Paul? Thank you. Yes, it's design exploration extension. My mind drew a blank there. So yeah, and that's something that's a capability within Creo that you already have if you're a Creo user. This thing is fantastic. So the recording to the webinar will be sent out probably tomorrow. Last week's webinar, I believe, was already sent, but I will double check just to make sure. Once again, thank you everybody for being on, and have a great day and weekend. Take care.